Good morning, my dear students. Today we will solve a formulation of LPP problem. So in this PPT, in this video, I'm going to solve two problems. Okay. So in all the formulation problems, questions is very lengthy, but answer is very short. Within half page, we can going to finish. But only when you are understanding the problem very clearly. Okay. So here I will read the question like this. They given a manufacturer produces a two types of model M1 and M2. Each model of type M1 requires a 4 hours of grinding and 2 hours for polishing, whereas model M2 requires 2 hours of grinding and 5 hours for polishing. Here there one company is there, that is manufacturing company. They are producing a two models M1 and M2. For that for grinding it require 4 hours and polishing 2 hours for model 1, and similarly for model 2 it require 2 hours and for grinding and polishing is 5 hours. So the manufacturer has 2 hours grinder and 3 hours, that is the manufacturer has 2 grinders and 3 polishers. They are having 2 grinders and 3 polishers. Each grinder work on 60 hours a week, in a week, and each polisher works on a 50 hours per week. Okay, just to multiply 60 into 2 and 50 into 3 will get the objective function. Okay, here the profit of the model M1 is getting 4 rupees, and model 2 M2, that is rupees 5 rupees. How should the manufacturer allocate his production capacity to the two types of the models, so that he may make the maximization profit in a week? So they are asking what, how should the manufacturer allocate his production? So which man going to allocate which person, so that manufacture that so that the profit will become more. Okay now, so formulate it is a linear programming problem. Like this you have to formulate the given problem. Okay, so read the question twice thrice in the model 1 LPP problem, because answer is very short if you are understanding question is clearly. Okay, so here there are two models are there. Let them assume the decision variable x1 and x2. Okay, now for model M1 and M2, therefore x1 and x2 treated as a decision variable. So objective function since it is a belongs to profit problem, they are asking profit, therefore you add both the values here, that is 4 and 5. That is maximum of z is equal to 4x1 plus 5x2. If you wrote like this, means if they are asking 8 marks, means they will give 2 to 3 marks for writing only this maximum of z is equal to 4x1 plus 5x2. Okay, so next we have to find out the constraint. Okay, constraint what? Here there are two constraints for one for grinding, another for polishing. Two grinders are working, so therefore the number of hours available for grinding is equal to what? 60 into 2, that is 120. So for model M1 require 4 hours for grinding, and model M2 require 2 hours for grinding. So hence the grinding constraint is given by, here they are given profit, so add it, 4x1 plus 2x2 is equal to less than equal to 120. This is the first constraint for model 1. Similarly for they are having 3 polishers. Okay, 3 polishers equal to a total number of available polishing is that is 3, that is 50 into 3 is equal to 150 hours. Just to multiply here, they are given in the question require 2 that is require a 3 hour for polisher per week. So 50 into 3, just to multiply, will get 150. Okay, so second constant is 2x1 plus 5x2 is less than equal to 120. Why you are going to add here in the both the constant? Because this problem belongs to maximization. So now negative restriction is what? That is where x1 and x2 should be greater than equal to 0. So the answer what we got from this is, formulation answer is maximum of z is equal to 4x1 plus 5x2 subject to a constant of 4x1 plus 2x2 less than equal to 120, 2x1 plus 5x2 less than equal to 150, and where non-negative restriction is where it should not, x1 and x2 should not be greater than equal to 0. So this is about the answer. Only 1 2 3 4, if you wrote 4 lines you will get around 6 to 8 marks in the examination. So just to understand in this problem, formulation problem, read thoroughly in the question. Okay, now this is about the first problem answer. In the second problem, they given what, second problem, I will rewrite the second problem here. They given in it is belongs to company. Okay, an oil refinery uses a blending process to produce a gasoline. In a typical manufacturers, crude A and B are mixed to produce a gasoline G1 and G2. Okay, the input and output of the process as given in the below table, that is process 1 and 2, and the inputs ton, it is given in terms of tons, and output crude A and B is equal to 5, 6 to 5 and 6, 2 and 8. Here the output what we are getting from that one is 6, 5 and 8 and 7. So that is the availability of crude A is only for 200 tons and B is 500 times. Okay, just to remember this. Market demand is for G1 is 150 tons and G2 is 200 tons. Profit on the process 1 and process and the profit on process 1 and process 2 is of rupees 300 and 500 per ton. They are getting profit for process 1 is 300 and process 2 for 500. Okay, what is the optimal mixture of the two blending process, so that the refinery can be maximum its profit. So they are asking what is the optimal mixture of the two process, of the two combined blending process, so that we are going to formulate. Okay, so here again, here there are two factory, again there are given, consider here again there are decision variable, that is x1 and x2, for the number of tons produced by the process 1 and process 2. Here process only, there are two processes are there, so assume x1 and x2 be the decision variable. Suppose process 3 means x3 also you have to take, so that the objective function is what, this is also they are asking belongs to profit. So just maximization is equal to z of 3x1 plus 5x2. Okay, why you are adding here, this problem belongs to maximization, they are asking what is the maximization. Okay, z is equal to 3x1 300 x1 plus 500 x2. If you wrote in the examination only this, you will get around 2 to 3 marks. Okay, so this is about the first step. Now calculate the constant. How to constrain the constraint as per the statement given in the question, 5x1 plus 6x2 is less than equal to 200. Okay, 5x1 plus, just to add here, it is belongs to, I shown here in the table, second problem table, wait here, second problem, 5x1 plus 2x2 is less than equal to, that is they given profit. Similarly 6x1 plus 8x2, again here 6x1 plus 8x1, 5x1 plus 7x2, like that you have to write here in the given question. Okay, so here write 5x1 plus 6x2 is less than equal to 200, 2x1 plus 8x2 is less than equal to 500, similarly 6x1 plus 5x2 less than equal to 150, 8x1 plus 7x2 is less than equal to 200. From the given table only you can write. Okay, now but your condition is in this problem is you need to calculate the maximization. Okay, first, so now the answer for this problem is maximization is equal to z of 300 x1 plus 500 x2 subject to constraint of 5x1 plus 6x2 less than equal to 200, 2x1 plus 8x2 less than equal to 500, 6x1 plus 5x2 less than equal to 150, 8x1 plus 7x2 less than equal to 200, and where the constraint, that is a non-negative restriction, should not be x greater than equal to 0, that is x1 comma x2 is greater than equal to 0. Okay, now so here this problem is very important. So in the question in the table only they given 90% of the answer. Okay, just to think about this, write the maximization equation and constraint. So only for writing these 4 or 5 lines you will get 8 to 6 to 8 marks in the examination. Okay, so this is about the formulation problem of LPP. Okay, so I solved so far 3 problems, so all are very important problem, go through it. Okay, thank you.